Hello, my dear friends. Welcome to the class of 12th English Medium. The subject is Statistics, Part 2, Chapter 4, Limit, presented to you by Vitan sir. Now, sometimes the questions are given the values which contain square roots. So, what to do then? We will see some illustrations based on solving such values. I will start with illustration 20. Here the limit x tends to 0 under root 3 plus x minus under root 3 whole divided by x. This is the question given. Now in this case is what can we do? First of all, we will write down the question as it is. Now when we look closely to the numerator, can we relate it with something like this? See, we will take 3 plus x root as a single value, that is a, and root 3 as another single value, that is b. So we can convert that actually to a minus b. Now we know that if we multiply a minus b with a plus b, we will get a square minus b square. The always the confusion in this kind of questions are how to remove these root squares. So what we are going to do, by a square minus b square, we are going to remove the roots again the squares. So in the next step, what I am going to do, I am going to rewrite the numerator. The only difference is the minus sign will be converted to the plus sign. It will be something like this here. We will write down the original value as it is and then multiply the numerator with the same numerator only with positives. And if we are multiplying something, we have to divide it with the same value to maintain the balance of the equation. So what I have done, compare the two numerators. Can you convert them into a minus b and a plus b in your brains? The 3 plus x root is a, root 3 is b. So a minus b in the first part, a plus b in the second part. Just ignore both the denominators right now. The main part is the numerator here. Okay, so when we multiply these two numerators, it will be converted into a square minus b square. But before that, I am just going to make them in a single uh, division here. In the next step, I will be converting the numerator into a square minus b square format like this. Root 3 plus x whole root will be a square. So square is there, minus root 3 will be the b square. So again a square is there. The denominator will be as it is. We are not going to touch the denominator right now. The important part is the numerator here. So as you can see, the a minus b was given. I added a plus b with my own intentionally, and then I multiplied them to find a square minus b square. So what is going to happen? The square root will be cancelled against the square. So just 3 plus x minus 3 will be remaining. Yes, that's what I wanted to do. I wanted to remove the square root. So whenever these square root kind of questions come, the first priority should be how to remove those square roots. So as you can see in the numerator, the square root has been removed and the remaining value is just x. 3 is positive, 3 is negative, that will be cancelled. The remaining value will be x upon x. So of course I am going to cancel both the x's, and once I cancel both the x's, I will take limit x is equal to 0 and I will put that 0 into my equation here. So it will be something like this. X will be cancelled, root 3 plus x, x will be 0. So 3 plus 0 is just 3. And when I simplify this, I will get 1 upon 2 times root 3 and the sum is over. Yes, this kind of limit is possible. Okay, so whenever these root kind of questions are given, just check whether they can be converted into a minus b format or not. If it is possible, then multiply them with the a plus b format. If you are multiplying, then also divide. Remember that to balance the equation it is necessary. And then once you get a minus b format and a plus b format, multiplying them will get you a square minus b square format, which will remove your roots in the question. And once your roots are cancelled, you can cancel the numerator with denominator and then put the limit value in the equation to find the exact limiting value for the equation. We will take one more illustration depending on this. The illustration 21 question is given, limit x tends to 2 root x plus 7 minus 3 upon x minus 2. Here only one root is there, but nonetheless it can be obtained using the same method. X plus 7 root will be considered a, while 3 will be considered b, and we will get the same method. So what we are going to multiply here this time is x plus 7 root plus 3. Yes, the negative minus will be converted into plus because a minus b and a plus b formats are there. And if I am multiplying, I also have to divide. Okay, so now I will combine both of these numerators and denominators into a single value, and then once I multiply them, I will get x plus 7 root square minus 3 square. So you see here the x plus 7 square root and square will be cancelled. So I will just have x plus 7 and 3 square will be 9. So that way I will get x plus 7 minus 9. The denominator will be as it is. Now plus 7 minus 9 keeps me with x minus 2. Now miraculously you get x minus 2 in the numerator and x minus 2 in the denominator. Actually it's not a miracle, it's an intended question. Always remember that in examinations, in textbooks, the questions are actually framed in a way that you can solve them. They are not haphazard questions, they are questions prepared specifically so that you can solve them in a particular manner. They have been simplified for you guys here. So we can cancel x minus 2, x minus 2, and then in the remaining equation we will put the value of x is equal to 2. So that way I will get 1 upon x plus 2 plus 3, 2 plus 7 plus 3, and when I simplify that it becomes 1 upon root 9 plus 3. That way 1 upon 3 plus 3, the answer will be 1 upon 6. Next is illustration 22. We have to find the limit h tends to 0 f x plus h minus fx upon h. Now till now this doesn't seem like a square root question, but there is a twist in the story that fx is actually root x. So now this has become a question which contains a square root value. First just write down the equation as it is in your notebooks. Now what we have to do before solving this equation here, that we have to write down that if fx is root x, then fx plus h becomes root x plus h. So these two values we will replace them in the equation with the given values, and it will be something like this: fx plus h minus fx upon h becomes limit h tends to 0 root x plus h minus root x upon h. Now, of course, what we are going to do is a minus b, a plus b here. X plus h root is a and root x is b. So we are just going to multiply them with this similar value, just having positive sign in the place of the negative sign. So we are just multiplying this very similar to the last two sums. Now the numerator will be converted into root x plus h whole square minus root x whole square. So these squares will be cancelling the square roots into our equation. So we are going to write x plus h minus x simply like that, and the positive negative x's will be cancelled, and we will be left with only h in the numerator and one another h in the denominator. So both the h's will be cancelled, and what we will be left with is 1 upon root x plus 0. Why 0? Because h tends to 0. So we are going to write 0 into that equation. That would be left with 1 upon root x plus root x. That makes it 1 upon 2 root x. Yes, that's how we are going to do it. Now let us take a sum where square roots are given in the denominator, and the numerator we can factorize it. X cube minus 8, we have to factorize this numerator, else we are not going to do anything else. So x cube minus 8 is a standard format, that is a cube minus b cube. Here 8 is the cube for 2, so it is actually x cube minus 2 cube. And if you guys remember it properly, it becomes x minus 2 into x square plus 2x plus 4. Now these are some of the standard forms which you must have studied in your 7, 8, 9 standards, and you must remember them for further studies. I am again recalling you that please refer those forms properly. Now, so numerator factorization becomes x minus 2 into bracket x square plus 2x plus 4. And now we will move forward with our regular limit question here. Limit x tends to 2, x cube minus 8 upon root x minus root 2. So here the denominator is a minus b here. So we are going to multiply that, the numerator and the denominator, both with the a plus b format, that is root x plus root 2 format. So both will be multiplied with root x plus root 2. The denominator, you can see a minus b, a plus b here. So when we multiply both of them, it becomes what we are going to write in the numerator, it is going to be as it is, but in the denominator it becomes root x square minus root 2 square. So squares will be cancelling the square roots into the equation, and we will be left with the factors of the numerator plus the a plus b format divided by just x minus 2. Now in the numerator and denominator, x minus 2, x minus 2 are there, we are going to cancel them, and the value of x, that is 2, I will put it into the equation here. So I will be left with, before I do that, I have just cancelled them for the sake of simplicity. Now I will put the value of 2 into the equation. So 2 square plus 2 into 2 plus 4 into root 2 plus root 2. So at every place where x was there, I have replaced it with 2. I will be simplifying it. It's a very simple thing. 2 square is 4, 2 into 2 is 4, root 2 is root 2 just. So 4 plus 4 plus 4 is 12, and 2 times root 2 is 2 root 2. So 12 2s are 24 root 2. So the answer for this illustration 23 is 24 root 2. So it doesn't matter whether your a minus b format, the square root values are in the numerator or denominator, you are going to multiply both of them anyhow. Let us conclude this tutorial with a bit lengthy sum. This is a question which has two square roots, one in numerator and one in denominator. Now this kind of sums are actually easy. They are not that tough, but they are a bit tricky. If you make a mistake somewhere at multiplying or assuming the value, it becomes difficult to solve them accurately. So same concept is applied of a minus b, a plus b. But the thing here is that there are two a minus b formats here. Numerator also has a minus b and denominator is a minus b too. So whenever we are multiplying with a plus b, we have to take two a plus b's here. One for numerator, one for denominator. And our problem is that if we are multiplying a numerator with a certain value, we have to divide it. If we are multiplying a value with a denominator, we also have to write it in the numerator. So it just becomes a lengthy sum, that's all. It's not difficult in any manner, it just needs a bit of a concentration. What we are going to do, we are going to start by writing down the question as it is. Now whenever we are writing down, just start with the numerator here. So once again, write down the value, then multiply the numerator value as a plus b format, then divide it, and then take the denominator value and then multiply it. Getting my point here? First we took root x plus 3 plus 2, that is the numerator opposite numerator a minus b, so it becomes a plus b, and we are going to divide it with the same x plus 3 root plus 2. So the first part here is the numerator thing, whole numerator thing. Then the denominator is x plus 8 root minus 3. So next part is root x plus 8 plus 3, and multiply and divide the same thing. So are you getting my point here, that because there is a one root in numerator, one root in denominator, we have to take two steps rather than just a single step. So in the numerator, x plus 3 root minus 2 and x plus 3 root plus 2 will be multiplied. For the denominator, x plus 8 root minus 3 and x plus 8 root plus 3, these two values will be multiplied. The remaining values will be left in the brackets, and they will be solved at the end when we are going to put the limit x is equal to 1. So right now I am separating these values here, which is a minus b, a plus b formats. Numerator, I have separated them with block brackets. Similarly in the denominator, I have separated a minus b, a plus b formats in the block brackets here. As you can see, in the numerator, x plus 8 root plus 3 is separated. In the denominator, root x plus 3 plus 2 has been separated. So that I am not going to touch till I put the value x is equal to 1. what I'm going to work with are those are the values in my block brackets. So now I will take a square minus b square format out of the numerator and denominator both. For the numerator it is x plus 3 root square minus 2 square, remaining is as it is. In the denominator it is x plus 8 root square minus 3 square, remaining as it is till the end. Okay, so I am going to remove the roots, but 2 square will be 4 and 3 square will be 9. So x plus 3 minus 4 makes it x minus 1. Remaining values I am just copying down, I am not changing them. As you can see in the denominator, x plus 8 minus 9 is again x minus 1. So now I will be cancelling x minus 1 with x minus 1, both will be cancelled, and I will put the value of x is equal to 1 into the equation now. So it becomes 1 plus 8 root plus 3, 1 plus 3 root plus 2. So when I simplify it becomes root 9 plus 3 upon root 4 plus 2, that is 3 upon 3 plus 3 plus 2 upon 2 plus 2, that is 6 upon 4, and the answer is 3 upon 2. So the limiting value for this illustration, this function, is 3 upon 2. So thus these double root questions always have a higher weightage than the single root questions. They are a bit lengthy, they are a bit tricky, but nothing difficult there. You just have to take double values, double a plus b's for solving these kind of questions. With practice you will get used to it. We will be practicing these questions more afterwards. So next time I will come with that how to solve the standard format questions. When I gave you two standard forms, the first one was the polynomial. Actually we have been doing that form only. The second form, the x raised to n minus a raised to n form, which gives us the direct answer of n a raised to n minus 1, if you have forgotten. Next time we will be discussing that format questions, illustrations. Till then, stay tuned, stay home, stay studious, stay safe. See you soon.